In this video, we're going to be looking at discriminants, and discriminants tell us all about the nature of the roots. Recall your quadratic formula. So minus b plus or minus the square root of b squared minus 4ac. And it's all over 2a. So that's the quadratic formula that you used instead of factorization when you had to solve for x. So within this quadratic formula, we have a very important element or a part, and this is this part that lies under my square root. So when we talk about discriminants or the nature of the roots, this part that I've just blocked off there in red basically tells you everything that you need to know about the nature of your roots. So I can ask you, for example, what is the discriminant of something, and then I give it to you. So let's look at an example. Let's look at the following. If I have the following equation, 9x squared plus 6x plus 1 equal to 0, and I want to determine the nature of this root. So if I say find the discriminant or use the discriminant, then I'm going to say discriminant. So that is just my shorthand for discriminant. Sometimes I have seen people use a capital D, but that's not really IB terminology. So you can just use the triangle. The triangle is the shorthand for discriminant, and your discriminant is b squared minus 4ac. So remember, if you have a normal equation, it could have been written like this: ax squared plus bx plus c. So that's going to help us find equal to 0. That's going to help us find all the respective elements. So my b is going to be 6. So I have 6 squared minus 4 times a is 9 and c is 1. So I have 36, 6 squared, and 9 times 4 is also 36. So I have 36 minus 36, and this gives me 0. So that 0 tells me that I have 2 equal roots. So an example will be, an example can look like this. Where it touches that intersect there. So for example, 2. So you have 2 solutions, and both of those solutions come out to be 2. So there's a shortcut or sort of a summary that you need to know for all of this, and it is as follows. So the first one is, if your discriminant is greater than 0, then you have 2 different real roots. So roots is just your solutions. The next one is, if your discriminant is equal to 0, you have 2 equal roots. And if your discriminant is less than 0, you have no real roots. And as I'm doing this, I'm actually thinking, if I do it as an illustration for you, that might help. So for example, 2 different real roots might look like this, and let's say there is your y-axis, so that might be minus 3 and 2. 2 equal roots will be like the previous example, 2, and no real roots would simply just mean your quadratic function does not intersect your y-axis, so it would look like that. So basically that's your summary of what you need to know for different roots.